NIT Trichy. So we will start with Mr. Anish. Mr. Anish is a DGM in Cochin Shipyard, and he plays a key role in shaping India's maritime industry because he leads the innovation cell there. So innovation, sustainability, and advanced ship technologies in Cochin Shipyard come under him. He is also the team lead for another vertical in Cochin Shipyard, that is strategic and advanced solutions. So many new things which are planned for the future come under him. And so it will be a real privilege for us to listen to him today. His work on India's first hydrogen fuel cell vessel is really noteworthy. And what advances we have made recently in this area is good for our country. He is good not only in technical and managerial leadership. As we heard yesterday, for every one employee in a shipyard, we may have 6 or 7 employees outside, other people working in that. So we need an ecosystem. All industries need an ecosystem. And Anish has been wonderful in developing that ecosystem for Cochin Shipyard. Welcome, Mr. Anish. Thank you very much for joining us today.
Hello. Hello. So, good afternoon, everyone. Thank you for giving me an opportunity to present my organization's prestigious project to your understanding. So, what I am here to talk today is about learnings what we have done from India's first hydrogen fuel cell ferry. So I'll run through these things. First is that I wanted to, I believe most of the people might have already done is to set a context why we should actually switch to hydrogen or relevant alternate fuels. We walk through the fuel cell technology. Then we will understand how we are going to integrate these kind of technologies with respect to the standards, safety, and regulation on board the ships. Then we will discuss on how a typical powertrain or the propulsion train happens in these kind of new developments. And then we will present the case of hydrogen fuel cell ferry. So I will rush through these kind of things because I will be focusing more on the hydrogen fuel cell side, because this you may be pretty much aware. First is that we have to understand that we as an human beings, as well as each country, we have to have a proper understanding of the greenhouse gas reduction, what we should do. So we can only do 100% greenhouse gas reduction only by switching to alternate fuels, including hydrogen. So what happens is that maritime is the one space which has been contributing approximately about 2.5% of the GHG emission globally. So of which we are approximately contributing to around 6% of the global emission. So we are committed to reduce this. So in order to do that, we can only do it through policies and by adopting latest technologies. So also we have to also understand why we are switching to fuel cells, specifically with respect to maritime. We have to control the GHG, SOx and NOx and particulate matter. So which is not happening when we switch to hydrogen fuel cell based solution. We will have reduced, and frankly, when we started hydrogen fuel cell for the first time, we were waiting for some sound to happen. And the only sound that was happening was the sound of the compressor, which was used for the compressing of the air into it. And there was no other sound. And the output was only water with some heat. So around 70 to 80 degrees, we were getting around on the fuel cell stack internally. And those heats were not getting radiated outside. But there was no other thing happening. So we were really, first thing we were trying to understand whether it is running or not running. Then only when we saw the output of voltage coming as 650 volt output coming to the DC grid, then we have found that yes, it is running. So that is my personal experience with hydrogen fuel cell when we started working on it. And secondly, the energy efficiency, it is highly efficient when you compare with an IC engines and other related, we can go up to whatever efficiency we have now coming is around 56%, and we can extend it by, it can be again increased. So we can increase it by absorbing more heat from the other process parameters. I think this has already been taken. What is a fuel cell and how does it work? This picture is actually a fuel cell stack supported by one company known as Ballard. I will also skip because I believe this has been taken, the working of the fuel cell. So this is very important. You see here, sorry. Typically, typically an installation of fuel cell happening on board a ship, this will come in the form of a 40 feet container with one part handling the fuel cell, and this is known as the BOP, balance of the plant. This will be a fuel cell plus a battery part integrated onto it. So you will see only a container in the on board the ship. If it is so that this is something like a plug and play. If you are planning to integrate within the engine room, then this entire fuel cell stack and this BOP will be a fixed component. You can either do it as a containerized solution or a fixed solution. But typically what we have seen is that now the adoption is happening is with respect to a containerized solution, so that the entire thing can be plug and play. So we will also understand what are the typical fuel cell technologies which have been experimented over a period of time in the maritime space. This proton exchange based solution. Then we are working, what we can understand from the international research is that specifically on the proton membrane, exchange membrane and solid oxide are the two promising technologies which have been now leading the show. With specifically the proton membrane solution is used in the small short shipping and in the long distance application, we are it is understood that there are solutions happening on the solid oxide fuel cell based solution. In the similar manner, this one, in the similar manner, ammonia as well as methanol is also getting more coverage as an alternate fuel. But I will restrict my talk specifically on the proton exchange membrane because that was the solution which we have used on board our ship. This is a very important thing. I would like you to focus on this because what we have done in our project is that we have associated with a company known as KPIT Technologies, who are who is based in Pune, who was primarily into automobile grade fuel cell. So first thing was that we have to understand that if you want to integrate a automobile grade or any industrial grade component on board a ship, we have to follow something known as standards, safeties, and regulations. It is not like that we just comply to certain things and we can simply integrate. It is not that easy. And the critical part in integrating is understanding and how are we complying to functionally to these regulations, because some of the regulation may not be practically possible with the component. Because when we do a pilot project, what we typically do is that we try to integrate functionally each of and comply to the functional requirements of all these regulations, ensuring that we don't do any what I can say, any lenience on the safety part. There are certain areas which can be a wish list part, which can be taken further as the research as well as the adoption is getting a traction. So first thing we have to take care is of the gas detection leakage system. It's a very critical system, as Professor has earlier indicated. It's a very critical system because I hope you are aware that you cannot see hydrogen and you can only feel it when there is a fire. So you have to use thermal based cameras to understand that there is a hydrogen flame is there, and you can only understand it through a flame or through a heat. So this gas detection system, then the ventilation or all the process parameters have to be explosion proof systems. Means it should not by any means create a spark which can ignite the process hydrogen. So we have to be sure that all the process parameters or the process equipments, specifically the electrical component, should work on a low voltage. Means the low voltage means it will be typically of 24 volt or 24 volt DC or less, so that the basic energy levels are not there to create a spark. There are other methods where you can use something known as an intrinsically safe system but the problem is that those intrinsically safe systems are used only for the measurement and monitoring purpose. But for controls, we will require higher power, for which we will ensure that those systems are explosion proof systems. And we will also have hydrogen codes and standards. Then what we do is that we will do a lot of, when we do a design, we do something known as an FMEA, that is known as failure mode effect analysis, where we ensure that we create all the scenarios with individual subsystem. Each of those subsystems, what we do is that we will break it down into each scenarios, and as we go, we will see what were the hazards we have modeled and what was the mitigation we have taken. So those things we will have an understanding. Also, we do a lot of risk assessment, because you have to understand, you are doing it for the first time. What was happening was that
പെൻസിലല്ലേ ഒന്ന് വായിച്ചാൽ മതി കേട്ടോ അതൊക്കെ.
Yeah. Okay. So, okay. Sorry. So what was happening was that when we have initially envisaged this solution and we were ready to start the trials, nobody was willing to onboard the ship, because people were really scared, because they were having a feeling. So we have to do a lot of sensitization, sensitization, and we also need to create some kind of a standard operating procedures to ensure that all the people and the safeties are compliant. So it was a cultural change which happened in shipyard when we were doing this. And second thing is that you have to also understand, when we are putting something on board ship, it should comply specifically to IMO, that is International Maritime Organization Convention and Codes. Then there is an International Association of Classification Society, that is IACS, and IRS is also a member, and IRS partnered with us in this project. So what we do is that there are a lot of international standards which we need to comply, and we also need to comply the technical standards such as ISO, IEC, and IEEE. So what happens is that initially all these things, we do something known as a gap analysis. What we do is that we do analysis of each subsystem, whether each of those subsystems are complying to the relevant class standards functionally. If not, it is not happening. Then what we do is that we will take methods so that the steps can be mitigated to ensure that the system is compliant for a maritime use case. The next part is that once we are done with that, we have done the gap analysis. Now we will create a solution which will be useful for a maritime use case. So first thing is that we try to understand the operational condition and the profile of the ship. Means how much hours it will normally run, how much hours will be available for charging, what are the infrastructures will be available, whether there will be a battery-based solution will be available, whether shore charging will be available, how many hours continuous will be required, what is the endurance for the ship, do we have a possibility to recharge the hydrogen on the go. All those things we choose, and based on that, next is that we choose the fuel choice and the hydrogen supply system. Third point is the very critical point. We have to understand the footprint, that is the weight and the sizing limitation. This is a very critical thing. What the picture is actually showing, this is an actual fuel cell integrated in one of the vessels by a company known as Corvus Energy. In the similar manner, what we have done is a 48 kW fuel cell. This will be in the range of one cell typically of this sizes is around 200 kW. So probably this is a megawatt scale power. As you are aware from the propulsion and the sizing perspective, you will typically the propulsion train will require minimum megawatt range power to create this kind of long duration, long endurance solution. So based on that, we have to select what is the fuel, whether we will use basically the gaseous hydrogen or liquid hydrogen, or we will use a hydrogen carrier so that we can optimize on the footprint. Once we have done with that, then we will do something known as sizing of the fuel cell stack. That will happen because you have to understand that fuel cell will not work alone, because what happens is that the response of a fuel cell, specifically an PEM fuel cell, is very slow comparing to the IC engines and comparing to the other prime movers. So when there, because as we go in the go through the operating profile of the ship, there will be maneuvering happening, there will be underwater currents will happen, there will be wind. So what happens is that the requirement or the demand happening on the propeller will change very frequently as we are going in different speeds in the different profile. So that has to be suitably augmented by supporting it with other renewable sources. One critical thing what we have been using is batteries. So what we'll do is that these batteries will ensure that whenever there is a peak power requirement happening in the load happening on the BESS, then that will be suitably compensated by the battery, because battery, as you are aware, it has got a fixed amount of energy associated with it, and the response time of a battery compared to an engine is far, far better. So it will respond during that peak power requirements, and by that time we can use a process parameters to improve the load demand happening on the fuel cell, and we can compensate it gradually. So whenever there is a peak power requirement, it will be adequately compensated by similar requirements. We can also use the case of supercapacitors also in the similar application. There are use cases, and we also wanted to try in future the supercapacitor use case. So these were some other requirements which we are bringing. And another one is the safety system. How we are going to do the emergency shutdown of the solution when there is a leakage happening, or when there is a critical process parameter is getting reduced, or if it is going out of hand. Third, and another important aspect is the durability and reliability in the harsh condition, because maritime use case is a very harsh environment. How do you ensure that the mechanical and the design parameters, as well as the material content which we have used for the these subcomponents, will stay and do the required functionalities for a longer duration in such a harsh condition? That also we do with our reliability analysis. And once we have done all those things, we will do multiple certification and the multiple methods to ensure that the certification and the compliance is done. So now I will briefly explain how a typical fuel cell process happens. So it's a very simple process. We have so what does the fuel cell do? It will typically take hydrogen and oxygen, and once the output is basically a voltage. Sorry. Output is voltage. So I'll once again tell it is hydrogen plus oxygen, and output is the electric current, but with some heat happening. So in order to ensure that this process is completely for running in a continuous mode, you have to ensure that whatever heat happening in this fuel stack is suitably collected and taken out, so that this is kept at the optimal operating temperature. In case of a PEM cell, the operating temperatures are around 60 to 70 degrees. We have to maintain this temperature so that those temperature parameters are kept for the optimal output. So the critical parameters, what have now I will explain each line. So first we have hydrogen. Hydrogen is, in our case, we have considered it as a gaseous form. We have compressed the hydrogen in the range of around 350 bar. But when we tested, considering the PESO requirement, which is the statutory body for our with respect to the safety, we have considered only 200 bar for the hydrogen. So in our process parameter, even though the system was rated for 350 bar, we have kept the hydrogen at 200 bar using a pressure regulator. We have, and after removing the moisture and other part, we have given it to a dehumidifier, and from there the pressure was actually reduced to between 1 and 2 bar, and that regulation is on a PID control, and then this was inputted into the fuel cell. And in the similar manner, we have a compressed air. We have a big compressor. This compressor runs at around 12,000 RPM. And based on that, we have an intercooler and a fan, and then a dehumidifier, and it is given to the fuel cell stack. Then we have two critical things. Once we are doing this will create heat. So we have a cooling system which will be used to control this parameter. And also we have a primary cooling system to do it like this, where we have a radiator and a fan to take the heat out and cool this coolant which is going inside. This is a freshwater cooled system. We have used the similar thing because you have to understand there happens a leakage of electrical ions inside the fuel cell. So typically, if we use a normal secondary cooling system as what we have seen in the other cooling system available for the shipping, what happens is that there are two cooling systems. This will be a primary cooling, and then from here we use something known as a heat exchanger. Here we will cool it through a seawater. But if we use those traditional method to cool for a fuel cell, the leakage ions coming from here will get affected through that, and we will have a earth leakage problem in the DC switchboard. So in order to mitigate that, what we have used since this was a low power solution, we have not used those consideration. We have used a radiator to see that it is isolated from the that seawater solution. This is a freshwater cooled solution, and this is a deionized water. We also have a we also have an ion detection facility in that, so that whenever the iron concentration is getting improved beyond a particular limit, we will shut down the fuel cell. So we have to put some specific additive in that cooling system so that iron content is kept in the minimum. So what are the controls we are using for a fuel cell? First one is that output voltage we will regulate based on the load profile, and the current control we also do for based on. How do we do that? Is that how do we do the load control? Is that based on the input parameters? You increase the input parameters, accordingly the output parameter, as well as this DC-DC voltage controller will also, because the fuel cell will create a voltage up around 150 volt that will be converted to a equivalent bus voltage. In our case, it was 650 volt. So we have used that DC-DC converter to step in the voltage of 150 volt to 650 volt. So in the similar manner, we have done the temperature control, humidity control, and pressure control. Now, this is a very important slide because these are the critical integration facilities which are available, because since the fuel cell is comparatively slow in responding to the peak power load, we can use any of these parameters or any of these options to ensure that we are having it to respond to the dynamic load requirement. In our case, we have used batteries. So in future, probably we will use a combination of batteries and supercapacitor, because what happens is that if we use supercapacitors, the advantage is that every battery, it is possible to charge and discharge. There is a minimum number of number of cycles are available for each battery. So if we combine it with a supercapacitor, the battery usage will be reduced, and typically we will have a more optimized solution, so that we can have because typically an LFP battery will have a life cycle of around 3,000 hours. 3,000 cycles. So if we use probably a supercapacitor, it has 1 million cycles. So what happens is that But you have to also understand, we cannot give it up to the full power of this kWh for this supercapacitor. So we will use it for a very particular, it will be limited to a particular capacity only. So based on that, because it's very expensive, supercapacitor is a very expensive as per the current technology. So we will use it in such a way that it will become a hybrid battery and ensure that the response to the dynamic load will be curtailed mainly maybe around 80% by supercapacitor. And if it is not happening, then only the batteries will be used, so that it will give some breathing space for the fuel cell to come to that level using the load control. So typically a fuel cell in a larger, because this is, I am putting it as a reference diagram only. In our case, what we have done is that, as you can see from the first figure, we have kept this entire hydrogen cylinder bank and the fuel cell in this side of vessel. We have used a similar hull of what was used for the KMRL, the Cochin Water Metro. We have used the same hull. But what we have done is that we have removed one compartment and we have taken the backside, and we have ensured that all these things are the complete hydrogen fuel cell with the balance of plant was put at the back end of the thing, and with the conventional solution it was put. So coming back to the typical powertrain, how it works is that we will have initially the hydrogen storage. This will be limited, as we have discussed, specifically for the whether it is gaseous, whether it is or whether it is liquid form, or through some hydrogen carrier, so that this will be limited by the profile of the vessel. Then we will have this fuel cell modules. Then we have batteries, and we have switchboards and power electronics with the shaft and the propulsion system coming in place. So now coming to the actual thing. So this is the project what we have conceived, and I'm very happy to be leading this team for doing this solution. This is we can proudly say that it is a full homegrown technology. The basic learning what we have done is that when we did Cochin Water Metro project, we have actually taken support from lot of external outside companies, specifically foreign companies, to support us on the KMRL project. So from there, what we have taken a stand was that we wanted to do it on our own. So what we have done is that whatever integration was happening in this vessel, including the logic for the power management, load management, and fuel cell and the propulsion control solution, was developed, and we used some partners to implement it, and we were very happy that we could meet all the requirements and all the individual components. All the individual components. What we have done, it was taken from India. The only thing, the cell came from outside. It was assembled by Exide in India. The fuel cell came from KPIT. The switchboard, the power management solutions, and the vessel automation system, and all the other safety systems were fully developed in India using suitable partners. We also tried experimenting a solar cell pack of 6 kWh. What we did was that we had integrated the MPPT controller directly to our 24-volt system, so that we wanted to test it, because since the power capacity was very less, we didn't connect it to the propulsion plant or to the direct DC bus. This was connected to a 24-volt system, which was used as a backup and an emergency power source in our ship. And it was also, we tried all the options in that, and we wrote that algorithm also. And we are happy that it is working still fine. And our daily requirement is around 40 kg at 350 bar if you run the vessel for 8 hours. And the battery chemistry was lithium LFP, lithium ferrous phosphate. And so that is the vessel. So so the hydrogen systems, and it was kept here, and the batteries were kept here, and these are the solar cells. So this is the basically the single line diagram for our and simplified a single line diagram of our vessel. We had a DC grid of around 650 volt. We have a fuel cell which had 4 stacks, each of around 12.5 kW, so the combined power is around approximately 50 kW. We have 2 batteries coming in. Each battery, the approximate requirement was around 60 kW, but when we sized it and we could get only a battery of around 102 kWh because that was the available battery in that space constraint. So we have taken that. Then we have a BESS coupler. Then we have, so the complete vessel was divided into port and starboard. We have port side, we have a hotel inverter because all the major load, because as we are translating from a AC solution to the DC solution, because what was happening over the years, the major consumers and major things happening are in DC, are in AC. So we will require AC to DC converter or an inverter for doing those solution. And we have a propulsion drive for running the propellers. So totally it was divided into port side and starboard side. We have a BESS coupler. This design was happened after we have done a lot of FMEA. FMEA is known as failure mode effect analysis. So you can identify that even if this battery is gone, we can run the entire solution with this battery. So assume that we have a failure happening here. We can isolate the BESS and we can run it. And tomorrow, if this inverter is failed, we can, the entire vessel can be powered using this inverter. And if one propeller is gone also, still we can go to the nearest port using one propeller. So all these things happened after a lot of brainstorming and a lot of as a result of design FMEA before implementing it. This was all done before implementing the actual solution. Now we'll now we will come to the what are the learnings or what were we have done. First one is that it is fully indigenous technology development. The critical parameter was passenger and operational safety. Then we tried to standardize the components. Now this is a very important thing because since we are handling hydrogen here, we have to do something known as hazard study because we have to do because hydrogen fuel is a hazard. So how do you handle it? Because we have 2 sources of fire here. One is the battery, another is this is the battery and this is the hydrogen. So we have to ensure that we have to do some studies known as hazard study, which is approved by the classification or the statutory body, so that it is safe for operation. So that what we are actually trying to do is that when there is a hydrogen leakage happening, we have done something known as a dispersion analysis, so that when that hydrogen is actually dispersed into air, it is not that concentration is not enough to create a fire. All those things we have done. Based on that, based on the FMEA what we have done, we have ensured the risk analysis is done, and we have found methods to mitigate that. So even if there is a gas leakage happening, we will shut down the entire solution. The challenge already with respect to the existing vessel, I will tell you. See, typically for a battery-based vessel, you can ensure that when it is not under operation, you can shut down the entire system and there is no watchkeeper required. But for this, there is a requirement of watchkeeper because there is a hydrogen already stored there. So we have to ensure that even if the vessel is shut down, the safety system still needs to be operational. And if there is there is a problem happening, the suitable fire people have to be informed that there is an issue happening on board the ship. So all those things are the lessons what we have learned when we developed these kind of solution, because, and it is happy to say that we have done it fully indigenous. We have not relied upon any foreign collaboration to do that. So the biggest advantage was that those knowledge is available with us so that this can be scaled to the next level. So what were the hazards we have identified? First one is that high energy collision penetrating the hydrogen cylinder. So what happens if there is a vessel collision happening, and when such a things are happening, what is happening is that the Type 4 cylinders what we have used, will survive those things. And if there is a problem happening, there are some air vending mechanism which will do a controlled vending, so that since it is only 40 kg, it will be vended within a very short period of time. And rupture of cylinder is also handled in the same manner. Vessel collision pertaining to the fuel cell power installation. Internal leakage, some internal leakage happens, then the entire solution will shut down. And if there is a leakage happening in any of the valves or connections, we will detect the loss of hydrogen. And if that value is coming very fast and the rate is very fast, then we will shut down the solution. And when we are bunkering the hydrogen, if there is a leakage happening also, the system shall be shut down. And failure of electrical power conditioning system. That means assume that when the vessel is running and fuel cell is fine, but the output that this one failed. Fuel cell is fine, but this one failed. Then what happens is that we will shut down the fuel cell and the vessel will run in batteries to the nearest port. So all those things we have actually modeled, and we have identified that these are the hazards available, and suitable mitigation steps and suitable SOPs have to be made. Because what happens is that these SOPs, we have to teach the crew members, because then only they can take the appropriate action during the voyage. These are some new things, because typically the crew members are not accustomed to such a things, because when you are doing in a battery, in a normal vessel, these things are not bound to happen. So these were the challenges. One is that when you are using PEM, the hydrogen purity has to be this. So it was very difficult to get, and the hydrogen is right now very expensive. It's coming more than 1,200 rupees per kg. And so the hydrogen leakage detection and firefighting, this we have to do it in yard as well as we have to do it on board. So we have to deliberate a lot in creating those systems with our statutory bodies, because when the Indian Register of Shipping created those rules, we discussed them because we were all doing it for the first time. So it was a huge learning, and this system integration is the one thing where our team spend months on that to create this solution. It's not an easy task, please understand, because this is where you can understand that the simulation comes in a bigger place. And we are actually we did a lot of empirical studies only. We didn't do any simulations in this part. So now we are actually trying to do some simulation. There are some we are getting some support from academia to do those kind of simulations, and then training of crew members and our employees for the safe operation. This was done multiple times, and we did some multiple scenarios to ensure that before we take the ship outside in jetty, we tried it a lot of times, because we don't want to take a risk, because it was even though it was not complex, the challenge was that what happens and what was the reaction. Because the people who come to drive these kind of ships are typical what I can say in Malayalam, you say srang. So those people have absolutely no idea, where they only know that, okay, this lever means go forward, this lever means go astern, and then the steering wheel they know. Beyond that, they were not very clear. So our people have to be there. Right now, we are undergoing trials at Varanasi right now. So you can understand that we are in the the west side, because Kerala is southwest side. We went to Varanasi, means all the way down through the Sedu part, and then through Sri Lanka. This was taken to the Varanasi. So you will understand how much it took us, more than 95 days to take the vessel, because you cannot take this vessel over road. So it has to go through sea. So it was taken like that, and now it is operating at Varanasi, and now it is undergoing trials. So similar vessels are going to come in multiple places of India, specifically from the tourism perspective and the short duration perspective. And we also had a big challenge in setting up the DC and AC facility. So DC and AC facility, you have to understand, there are two ways of charging these batteries. One is that when it is on shore, you can directly connect the shore, means from the AC charger kept outside the vessel, you can directly connect that will be, DC will be given here and battery will charge. Then DC charging means when the vessel is running, whatever excess power this fuel cell is making, it will be used to charge the batteries. So those two facilities we had to create. And then another very important thing was to create, since the fuel was not available, we have to set a temporary fuel filling and dispensing facility, which we got an approval from PESO, because since we were doing only 40 kg, they were not very stringent about that, but we had to do a lot of work in order to create that. So with that, I conclude my presentation. Thank you. Now it is open for questions, if there is someone.
Yeah, floor is open. Anybody wants to ask some questions?
Sir, it's quite interesting to hear all this journey for a fully hydrogen fuel vessel. And actually, this work, this process is actually starting after installing, I think so, because there are a lot of hazard studies you have done, and also very interesting actually. There are a lot of questions in my mind actually, but may I ask some?
Yeah. It was a 2-year project, to be sorry for that. It was a 2-year project. We had to work on more or less more than a year for ensuring the various compliances in place, and then only we could do it. And when we integration took us 3 months. Because what we did was that instead of integrating directly on board ship, what we did was we did something known as an integrated trial, which means what we did was that this entire solution, this entire thing we simulated in the workshop. Means we actually, the switchboard, what was supposed to be kept on the ship, we transported it to the fuel cell facility. Then we wired it up like this. This was loaded using another motor. And so that we created all the scenarios so that we can tune the fuel cell as well as the power load conversion, because you have to ensure that how the power management controls between when to start the fuel cell so that batteries are kept at the required state of charge. That's a very critical thing. As budding engineers, you should understand the importance of battery and battery related terms. It's a very critical thing. So that was the main thing. So we could, even after doing that integrated trial took us around 1.5 months. After that, the entire facility was transferred to shipyard, and we did the trials. The trials was very fine. And then once we did for the full load trials, we understood that whatever we simulated, we could do in 80, 85. There were a lot of difficulties, and we could finally do that.
So it is simulated, hardware itself simulated in the.
It is an actual thing. We did the hardware in loop. No, it's not 100% hardware in loop. Means we did all the systems was physically simulated, not using emulators or simulators. We were luckily, because all the things were available. This was a choice which we took it in project management, because this was from my experience, because I was part of a lot of projects in shipyard, specifically even for the aircraft carrier project, I was responsible. So from that learnings, what we have understood that if you don't do it, these kind of tests, there is a considerable risk when you do it on board. It will take months, and you will not sort out. If you do it in a normal shop floor, you can easily change something, because on board ship you cannot do it like that.
So for all this fault related FMEA studies, actually what we have done, we will create that situation like a mock drill, then we solve it.
Yes, what we did was that what we did was, this was all done empirically, means we didn't use any software for that. What we did was that we created, it's like a mind map kind of a thing. What we did was that we put this SLD and then we started doing not a cascaded failure, but a single point failures. First, we attempted the single point failures so that we failed each item in a logical way, and then see whether the critical functionalities are lost. If it is not happening, then that's a go. Before. Yes. We did it first on paper, and then this was shown in the trials.
Sir, it was very good presentation. I have a query that whether this complete system can be composed in a one container size or
Yes.
one container?
Yes. This size, if you see, the fuel cell part, this one, this fuel cell part, what we have done, that 50 kW is approximately 1.5 meter by 1 meter, this size only. Can be fixed in that size.
On the previous layout, you have shown very first layout.
This is a 40-foot container. See, what happens is that this is a 40-foot container by ABB. You can do that. This is approximately, the capacities will be of the range of 500 kW, approximately 500 kW, plus batteries may not be available here. This is the fuel cell. This is the balance of plant with cylinders. Everything kept inside. And then there is one more small cylinder will be there, which will be cascaded for the batteries. That is how it will be kept on board ship. Without batteries, it will not, because it will not take that transient response.
So this ship is working in a hybrid mode or it's completely fuel
It
cell?
is always in the hybrid mode, because what happens is that, see, when it is running, the load demand, because the propeller demand is actually transmitted directly to the bus. So this bus will have the variant, that power will be always varying. So that variation, the response will be done first by the battery, because battery is directly connected. You don't have to look for anything. You will just discharge. So our choice is to ensure that when it is discharging, that rate we will try to compensate to ensure that it will not discharge beyond a purpose, so that the depth of discharge we will limit, so that the state of the charge will be always maintained at between 85 to 65. So that beyond 65 means the state of charge will be, means it is available for 65%. Beyond that, we will not try to discharge typically. If everything is going bad and if this is not available, the battery can discharge up to 20%. Depth of discharge will be 20, means 20% energy will be available, because it is required so that we can take it to the next port. And important critical thing is that if deep discharge happens for the battery, it is very dangerous.
And one fuel cell layout you have shown, in that, here.
This one SLD.
It is mentioned that you have to maintain fuel cell stacks in some 60 to 80 degrees Celsius.
60 to 80 degrees.
So if you're not doing this
Cooling.
heat transfer cooling, so what will the rise of temperature will be there?
What happens is that if what we have done is that the thing can go up to 85, then we'll trip the system. That is what we have done.
So
If one stack, there are 4 stacks in that. This box has got 4 stacks. If the one of the stack, the temperature difference between the other stacks is about 10 degrees, then we will trip that entire solution. That is what we have done. We don't want to take it, we don't want to stress it, because if you stress it, the what was told to me by the vendor was that the stack will, that membrane will fail.
Number will fail. Okay. Thank you.
Yeah.
Thank you.
All are PID controlled. Yes.
So we have that classical DC to DC.
So it's a standard DC-DC converters, MOSFET or IGBT based. Yes.
didn't incorporate any new technologies or control strategies as such.
Because we don't want to take, see, you have to understand the difference between when you're doing a commercial project versus an R&D project is that we have a definite timeline there and we have a definite outcome within that timeline. So you see here, this is a variable. So I cannot take a risk on this variable. See, what happens is that, see, in this project, let's assume, see, I'll tell you frankly, when we started this project, we were thinking that DC switchboard was very easy. Because we have years of experience in the AC switchboard, there was no problem. But it was absolutely wrong. So that was the hidden risk we understood, because what happens is that even though DC bus doesn't require any synchronization, because DC bus means there is only positive and negative. There is no phase is not there. So we thought that it was very simple. No, the selection of the contactors, we need to select something known as pre-charge. Means you cannot simply close this battery is there, the terminal voltage there. You cannot simply close another battery directly. You have to do it through a pre-charge. All those things, if the timing is not correctly done, no, we will lose that cell. And the selection of the fuses, those were semiconductor fuses, because it has to respond. Because what happens is that the tripping of the things are based on semiconductor fuses, which act very fast. So that was a hidden risk. Now, if tomorrow we use new techniques for these things, then this is an added parameter in our existing timeline, which we may not succeed, because that was not the primary motive. Our primary motive was to prove this solution that it is possible to integrate a fuel cell on board a ship. That was the primary motive. So we didn't do that. So probably in the next time optimization, we may do that.
Thank you, sir.
No, sir, what about the cost of the project? How much?
Okay, sir,
cost.
the project cost was approximately 20 crores.
20?
20 crores.
Oh, 20.
Because this doesn't involve our engineering cost. Because what we did was we were trying to do it. So typically the vessel cost is not covered using that. This is only a development cost, what we have done.
Okay.
So it's a very costly thing because fuel cell is very costly right now. So over adoption only it will come.
Is there any development in improving the efficiency of the?
Yes, sir. The current efficiency is around 56%. It's far better than IC engine. It's around 40, less than 40.
Your boat in Varanasi, what is it being used for?
Mainly, it is used. It will be used for the tourism, that is spiritual tourism, and
And what's the length of that boat?
length of the boat is
Cameron
around
boat?
30 meters.
I see. Okay. Thank you very much.
Yeah, thank you, sir.
Thank you very much
Thank
for a wonderful
Thank you.
talk. Listening to one presentation from an academic institution and another from a industry is very nice. Thank you very much.
Thank you, Sri Anishas, for that enlightening presentation on India's first hydrogen fuel cell vessel and eco-friendly ship innovations. We are grateful for the knowledge you are shared with us today. I now invite our session chair, Dr. D.D. Ebenezer, to kindly present a token of appreciation and a certificate to Sri Anishas. Sir, please.
Our next speaker is Professor Muthukumar. Professor Muthukumar is from NIT Trichy, and he is available online for us. And it's a privilege to introduce him. He has a ME in welding engineering from REC Trichy. So that was a few years ago. And then a PhD from BITS, Ranchi. And he has expertise in welding, boat design and fabrication, automotive materials, manufacturing technology, as well as material science. Perhaps the most important point while introducing him is that he is the inventor and patenter of the cost-effective Fjord boat. Fjord boat can be used as ordinary room furniture, maybe as a cupboard when times are fine. And if you have a flood in your neighborhood, you can use it as a boat. This is a groundbreaking innovation, and it deals with safety, and ordinary people can use it, especially during floods. Okay. He has more than 100 publications in leading journals. He has done research for ISRO, DRDO, and we welcome Professor Muthukumaran. He is online. Professor Muthukumaran, you have about 40 minutes to make your presentation, which means you will close at about 1 o'clock.
Very good morning. I'm audible, sir. I'm audible.
Yes, we can hear you.
Yeah. So it's a very nice occasion. It is very nice to see that State Department is celebrating Golden Jubilee. It's a milestone, and it's a nice opportunity to join the celebration because I think this is one of the oldest departmentship in the country. And with these few words, let me just highlight. Let me share my presentation. Kindly confirm whether it is visible. Visible, sir? It's visible?
Yes.
Yeah. Yes. Yeah, let me make it full screen. And first of all, I am thankful to Professor Madhiyadagan, the head of the department, and Professor Sivaprasad, sir. I have been collaborating with them for nearly 2-3 years, and Professor Madhiyadagan belongs to NIT Trichy. He is also alumnus of our NIT Trichy. And I'm happy that we have very good collaboration, and I'm sure that this collaboration would continue. And now I am going to just highlight about friction welding, fireboat, and the trash removal equipment. So I felt I am an odd man out because I am less related to ship, but I feel yes, I can share my experience and my contribution at this forum. Yeah. So this now we have Sustainable Development Goal. UN given the Sustainable Development Goal because we are getting due to climate changes, a lot of issues we are facing. Frequent flooding. Now also Chennai, there is a heavy rain, and this is happening. This become common now. And some countries, I just read paper that five flood they faced in 1 year. So UN is very keen in that climate changes. Climate changes is a very big issue. So 17 goals we have. In these, we can see life below water, clean action, climate action are very important. Climate action is very important, and ship department plays an important role. And I think my presentation, three topics. One is friction welding, and fireboat, and trash removal equipment. All the three are related to UN Sustainable Development Goal. So let me take very limited time and share my experience. And first, let me start with my specialization. My most part of my research is in friction welding process. And I'm happy to share that I am my paper is the first paper in this particular field in the country, friction welding. And my PhD is the first PhD in friction welding in the country. Then I given how the joint take place. And this is also very important. My first paper is metal flow phenomena and friction welding. So the friction welding, we don't use any shielding gas. And another thing is this particular process, it is completely different from other processes. Suppose if we take submerged arc welding, some 70% it is like mantle metal arc welding. If we take TIG welding, some 60 to 65% like mantle metal arc welding. So these are all developments, but this is a completely new invention. And how they invented also very interesting. The Welding Institute, TWI, because this is very, very relevant to shipbuilding. That's why I'm giving more importance for this process. I'll tell what are the component welded. Let me share after 2-3 slides. And so TWI, the Welding Institute, they were doing drilling operation, but accidentally there was a due to poor fixing, there was relative movement. So the fixture was not good. So they found that the hole which was drilled got filled with metal. So the hole got closed. Then they thought something is happening. Then they developed this as a process. So even though this is named friction stir welding, this is completely different from friction welding. So people started working, and when I started my PhD, I developed the machine myself at Birla Institute of Technology. But I was very much interested to know what is happening, because within a few minutes we can weld 20 mm to 20 centimeter length plate. At 1 second we can weld 5 mm. But there is no, we are able to get uniform welding, best strength. How it is possible? Because we are mixing, then also we may not be able to mix. But here, just a tool runs in the fairing surface along the joint line. The tool, it just runs, that's all. It rotates and it runs, joint is happening. So this given me some interest. I was not, that time even though I was doing PhD, my intention is to know really what is happening there. So when I saw the research, nobody attempted that. Just people took 6 series, yes, welded, good strength is getting, like that, most of the paper. And only 2 papers were there, that 2 published by, one is NASA scientist, another at Stanford University professor. And they also didn't touch anything about the metal phenomena. Then I thought something is there. Then I got some interesting idea, and then I proposed, then that got accepted. And even today, there is no theory to challenge my theory what I given. That is 2 modes of metal phenomena. That is, I think this forum is not right forum to discuss that. So, but this given me confidence. Yes, we can do some innovation. Yes, we can. It's not that you are only people in US, NASA can do. We can from India. We can do some good work. That given me a lot of confidence. With this confidence, I did some work. Let me share those works. And in shipbuilding, I hope most of you are aware of friction stir welding process. I'm not going to go in depth about the process. This is 2 plates are fixed and the tool runs. That's all. There are no filler, no shielding gas. There is no hazard, fume hazard, because Malan metal arc welding it gave rise to more than 35 diseases, because it lot of health hazard it carries. But here completely no smoke, no melting, and when metal melts, lot of issues it happen, oxidation, no oxidation. All we have many advantages with this process. So even 30 mm plate we can weld in 2 passes. 30 mm thickness, I'm telling. Thickness plate we can weld in 2 passes. Lot of advantages. Some other occasion, let me give exclusive presentation on friction stir welding. And now let me highlight only the application point of view. Yeah, shipbuilding, yes, it is widely used in developed countries in shipbuilding. So these are some of the component. We can weld a honeycomb panel, hull, deck. So particularly aluminum, very simple to weld, because tool design is very simple. But steel also, people now successful in welding. Even oil pipelines are welded nowadays by friction stir welding, because there is no less energy consumption. Because now, this is actually the ship. Wherever line you are seeing, this is the place welded by friction stir welding process. So it may not be feasible for us to manufacture complete ship right now in our country, but at least we can plan some panel. At least some of the panels in shipbuilding, particularly aluminum, I think we should explore this. I had a lot of discussion with the Cochin shipyard because now the carbon tax, you can see, you are able to see, I hope you are able to see, the carbon tax is going to be high. So this particular process, it consumes only 5% energy consumed by laser welding or any process we tell, it is currently, it is much less than the energy consumed. So energy saved is, we need to conserve the energy. Less energy consumes, less carbon emission happens, because we get correct power from the, mostly we are getting from from thermal power plant, like this. Some emission used to happen. So energy, we need to save the energy. So this is a very energy efficient process. That is the main advantages. So roughly some 5 to 10% energy consumed by other processes. Even some of the process consume only 2% of energy consumed by other processes. So this is very energy efficient process. So definitely carbon tax is going to be high in coming days because of climatic changes. Immediately some action should be taken. Now we can see that Delhi, our capital, we can see the lot of pollution level is very high. So definitely we are going to face carbon tax. Now it's right time to think green technology. So this is a green manufacturing process, particularly in shipbuilding. Welding consumes a lot of energy, energy intense process. So definitely we should think about the recent processes, energy efficient processes where we should work. So these are the advantages about the frictionless welding process. This is a clean welding process. There is no smoke, and it is green because it consumes least among the other welding processes. And we can get excellent joint strength. Even we can get more than 100% joint strength in aluminum alloys, because the grain refinement used to take place that they improve the strength. So we can tell now the weld zone won't get failed. The failure used to happen away from the weld zone. So even 30 mm thick plate we can weld without filler, shielding gas. These are some of the advantages. So, but there is a major limitation with this process. There is a major limitation. Major limitation is the flexibility. So wherever we can weld by arc welding processes. But here, this is solid state welding processes. Solid state welding processes, well, lot of forces are involved. So we need a setup to offer the force, and we should have a rigid machine to handle the force. So that is the main difficulty with this process. It is not a flexible. So wherever we need, we cannot go and weld. We should keep inside a machine. We can fix the component, and we should weld. So that is the main advantage with these processes. So we are free from emission. We can see a lot of advantages with these processes. So at least, even though it is not possible to adopt 100% in manufacturing, 100% fabrication, instead of aiming that, at least 5 to 10% easily we can work. And by research, we can improve the 10% to 20%, 25%, 30%. That is what research, as a research we should do, we should focus. So definitely we need arc welding processes, but this can be used as a better process wherever it is feasible. So this is the machine available in our NIT Trichy. Very few institutions this machine is available. So I made some attempt, and I could get this machine in our lab. And this is around 12 students, they completed PhD under my guidance in this process, different allied processes, friction stir welding and allied processes. And I welcome any research, any collaboration. It's my pleasure, and I extend my warm welcome. So ISRO, we did a lot of work. My group, as my scholars, they did, and we got some project, and many people got PhD related to ISRO project. And with this introduction, let me, so these are the patents granted. Basically, my work is friction-based welding process. So these are the 8 patents granted, and some of the patent already we transferred to industries. So this is another interesting, based on the experience I gained in friction welding, I developed a new process to weld tube to tube plate. Heat exchangers, this process is used. It is just simply the tool is moves, rotated and lowered, and tube plate will get joined. So this process, along with my student, I worked, and 4 students got PhD in different combination, NDT, and like that. We published almost most of the journals. We published article about this, and this is I named as friction welding of tube to tube plate using external tool. So this is to weld tube to tube plate, and without any using any shield gas or filler material. We did work, and titanium, we did project to IGCAR Kalpakkam and for to nuclear application. And UK, I got a project along with Leicester University to explore this process. So we did, we published jointly. And this is my, definitely this have a lot of applications in automobile and different manufacturing units. So this is a bond interface after tube to tube welding. It will have metallurgical bond, and this has a lot of advantages compared to other welding processes. So just let me run a clip of video. Such a tube to tube welding process. Steel is welded in the friction welding machine. So steel, the color change used to happen whenever it is heated, but aluminum, there won't be any color change even after melting. So the video I shown is tube to tube plate welding of steel, tube to steel plate. So we also welded steel to aluminum. So with this experience, I visited shipbuilding industry, many industries to know what is happening, so that some of the technology, whatever we developed, could be transferred. Then I learned that bimetallic welding is very important. Right now, you can see the left side, the hull is made by steel and the superstructure is made by aluminum. Because it gives better stability and also some defense. So it has a lot of advantages. So then I understood this is the topic, this is the area we need to explore. Because right now, the transit joint, aluminum to steel, now it is welded by explosive welding, and it's very expensive. Another thing I noticed is during fabrication, using the transit joint made by explosive welding, intermetallic formation is a very big issue. Intermetallic formation. So they're going for cold welding. So with the experience I gained, then I thought, okay, this area we need to explore, and so that it would be very useful to shipbuilding. And more, our Indian Railway, recently they started using aluminum body. So they also have a lot of application for this transition joint. Then with this experience, I developed this bimetallic strip welding. And I think I have one. Okay, later on I'll show that. Bimetallic strip welding by for friction route, and the process what I developed is not a friction welding. It is one side it is aluminum, other side can be steel, and it is a metallurgical bond as well as mechanical interlocking. And a good point about this process is the special cooling circuit incorporated in the welding itself, so that in weld itself, so that in fabrication there won't be any intermetallic formation. So we can go for pulsed GMAW, and we can carry out the fabrication, ship fabrication without any difficulty. Because right now intermetallic formation is a very big issue, but the weld what I made, I already tested. The transition joint, whatever I prepared by between steel and aluminum, there is no intermetallic formation at all. So because so this I filed, and now I am exploring. We working with collaborators, and Professor Madhivanan also involved in our research, and we are trying to establish as a process, particularly for shipbuilding. And we hope within a year we could give this technology, transfer the technology with standards. So that is what our direction. And then second part of my presentation is Furboat, as during my introduction, and they said about Furboat. FUR for furniture, E for emergency, BOIT. If you Google, you can find lot of videos about this. Any invention, because and also my interest is IPR, intellectual property rights. So I used to handle IPR as a global elective of my students, and I got opportunity to serve as a IPR head for 6 years. So I learned something about IPR. So whatever invention we do, and we should give special name for that, because later on, if you search in Google, only those related to those invention alone will come. So I framed the name. This FURBOAT is a coined name by me, and I trademarked this. FUR for furniture, E for emergency, boat. If you search Google, you can find a lot of articles and video clip about this. So that gives some uniqueness. So, and one more thing, then the NDRF I share, they invited me to give demonstration, and I told them, even if 3% sit and fill with water also, it won't sink. So they tried. They can see the image, 3% are sitting, and after filling with water, because the buoyancy offered by the side members, it won't sink. That is the specialty, because laymen, we cannot see, the laymen are untrained people, and in worst case, what will happen? It is filled with water and 3% sit, because more than 3% cannot be seated. So 3% seat or even 4%, it won't sink, because it is the buoyancy offered is more. And in a normal day, it can be used as a cot, furniture. And in case of emergency, we can flip it and use as a boat. That is advantage of this. And this is made by polymer matrix composite with a steel frame. And steel frame gives the stiffness, and polymer matrix composite. This is the composite I use is used in shipbuilding. So boat manufacturing, the epoxy resin I selected, and glass fiber used, and natural fiber also used. So once suppose I am living in a flood risk area, if I purchase this, I can keep for generations, because it won't get rusted, because whatever steel is inside this polymer matrix composite. So I can keep this for generations, and as a furniture also, no maintenance, nothing would happen. So that is the advantage with this FURBOAT. And the FURBOAT, I already saved thousands of people in flood. Let me share the video clip, and I'm happy to share that KUSAT, they helped me, and they studied, and the Professor Suprasad, I am very thankful, and he certified this after rigorous testing, and that given me confidence to give to the public. Otherwise, I would be keeping inside my lab. Only because of the support of Professor Sivaprasad, Professor Madhyagan, Mr. Soni, now I am able to give to people, because otherwise I would be keeping this in lab. So I take this opportunity to thank KUSAT and professors for their support, and they are guiding me, they are supporting me a lot. And another thing, one FURBOAT is available in KUSAT. I hope the audience they would be aware. When FURBOAT is available, I requested Professor Sivaprasad. He came all the way, and he supported, and he didn't take any honorarium for this assignment. So I requested, but he refused. No, you have done a good job. I don't want to take any. Then I said, sir, let me donate my own boat. So I donated one boat to KUSAT. It is available in lab, and I hope some experiments the professors are planning with this FURBOAT. That is the background of this. And Honorable Minister Sarkar, he released the first model of the FURBOAT. Then now I am happy that it served a lot of people during the flood. So now also 3 FURBOAT I given to Chennai Corporation. Now also they're using. There is today there is a lot of water logging, a lot of issues they're using. So this is very handy and very easy to transport, and a lot of advantages we have. Just let me show some selective video clip. Sir, video clip is visible, sir?
Yes, we can see it.
Yes.
We can see. Sir, what is it made of? What is the base material?
Yes, sir. Yeah. So one slide I have. Let's show you. Yes, sir. So this is the fireboard manufacturing process. It is a frame around 35 kg steel frame that can be reduced, but I given excess design. And the steel frame, first steel frame is made, then it is a mold. Mold is created. In the mold, we used to keep the frame, and we used to lay layers. That is it is five layers of glass fiber mat was used and epoxy resin. So by this we can manufacture this fireboard. It is a glass fiber and it is epoxy resin, and it is a steel frame. So this is a manufacturing method. I trained our scholars also, and now I am using this. I am collaborating with a board manufacturer, and now I trained the board manufacturer to make. Once this is given as a suppose if wherever flood risk area, this can be used as a furniture. Like just like fire, we have a fire extinguisher like that. Wherever flood risk, this can be used as a furniture. So in case of emergency, they can flip it and use as a board. So there is a background of this. And now I am going to, we are developing a fireboard. Some of the part we are planning to manufacture by mycelium. Mycelium is a fungus. So a fungus-based product, now fungus-based material. So that work we are doing now. So Honorable Minister inspected this during in 24. Dharmendra Pradhan, and definitely now the flood become common in our country. I hope this would be useful to say people. And yeah, so another application of fireboat is this can be used as a furniture in passenger boats, because now right now we are giving a life jacket as a life jacket. Many people do not know how to use, and moreover small kids and aged people, they may not know how to use, and they may not be able to use also. So in case of boat capsize, this can be used as a rescue boat, because we cannot keep rescue boat in boats, but this can be used as a furniture. I approached Cochin shipyard and I given demo in backwater. Yeah, they're fully convinced, and definitely I hope this will take up. And so another application is right side. It can be given to fishermen as a ice box. So by insulation, by keeping insulation, this can be given as ice box. In case of fishing boat capsize, this can be the content can be thrown, and they can safeguard the life. They can avoid sinking, because the fishing is considered most hazardous, very risky profession in the one among the risky professions, and every year thousands of people are killed globally because of boat capsize, fishing boat capsize, and this can be given as a ice box to the fisherman, and another advantage with this is, suppose if they some during in a year around 2 months there is a ban period, because the breeding, the fishing is banned in deep ocean. That time they can use this to do inland fishing. inland fishing, and also they can use for cleaning up the water bodies in the water bodies in inland water bodies. Because now I had a lot of discussion with fishermen. They say that during that period, it's really very big problem to them because they are very hard workers and they cannot keep idle, even though government is giving them some monetary benefit, but still that creates a lot of social issue. So definitely this is a win-win during that ban period. So they can use this for inland fishing and to clean the water bodies, so they can get additional revenue, and definitely this would help them to lead a very pleasant life. So this I discussed with Indian Oil Corporation to support to CSR. Yes, we are discussion is going on, and I will be happy if I get some collaboration. And moreover, this technology, the furboat filed international, that is PCT route. That is, it have protection in 165 countries. So I got a very good report that I can share. This fulfills the condition for patent filing. This is a report given by PCT. So wherever country we file, more opportunity, more scope is there to get the grant. So I'm looking for a collaboration internationally to file jointly and reach this to public people. So there is no such product is available, and this is a simple and but yeah, it has the application. And another application is the education sector, because in our institute I tried and it's worked well. So now new education policy is insisting for out of classroom teaching. So I took furboat in a swimming pool and I could teach them center of buoyancy and how to resolve forces and center of gravity and meta center. So all this I could teach, and I could see the interest shown by students. They are showing more interest if we teach this in the practically. Instead of that, if we teach in blackboard, it may not be that much interesting. So this is also having a lot of application in education sector. In fluid mechanics lab, this definitely they can add some 2-3 experiments. So that will give better understanding, not only ship department, in mechanical department. So this is the next step, what I am showing. So when I visited NDRF centers, I saw a lot of photos that they say that a lot of people lost their life during rescue. That triggered me to develop this technology. Here it flies as a drone and it couples with a furboat, and it propels them to safer location. So the fan part is vertical in case of drone. Then when it coupled with the furboat, it is now horizontal. It works as a fan boat. So this we filed a patent jointly, and it's order of grant. So this is the advanced. The aim is wherever flood risk, the furboat should be there, and unmanned rescue should happen, so that we can avoid loss of life. The people who are rescued are under heavy risk, so that can be avoided. So it flies as a drone. After coupling, it is like a fan boat. So it propels them to safer location. So this can be maybe this, but it needs a lot of studies. But we started working this direction. So this is having many application, and already I highlighted the flood rescue and AI based. So that's what AI based. In future it may come, but we just already started some work. Boat application is furniture come emergency boat, ice box, and pond fishing. Pond fishing, rod fishing. This is the best solution, and this can be used for that. And cleaning operation, cleaning. So this can be used in many ways in cleaning operation. When I took part in exhibition in Hyderabad, IIT Hyderabad, after the exhibition, the director requested me this furboat, that particular furboat, because they have very good ponds. So they requested for cleaning, then I donated. So that definitely it is having application in keeping the pond clean. So because it is affordable, and other days they can keep as a furniture in this particular board. That's the advantage of this board. And yeah, this is a patent, another patent I filed. And complete the IIT Madras, they interviewed me, Shastra magazine. It is available in Google, and it is 1 hour interview. It's available in YouTube. Anybody interested, you can you can see. My intention is to help people, so I am very open. Even if some free license also I am willing to give. And some people, if they get benefited, if people are getting benefited, we are happy. That's all. That is a main thing that I shared in my interview also. So then trash removal. So when I try to remove trash with the fur boat, sir, another 10 minutes I can take?
5 minutes, sir.
5 minutes. Okay, sir. No issue, sir. Thank you. Thank you. So the trash removal is a big problem, and water trash is a very big problem. And now we are using very large machineries, but small pond. I thought fur boat, I should develop an attachment. When I developed, whatever goes inside, that comes outside. So that triggered me to develop one interesting device. Then I think I can show this. Yes. Sir. So there is one non-return wall. You can see, very interesting. This is a simple. This can be fixed with handle also. That also. Super, sir. You can see whatever goes inside, that cannot come outside. Even you can see it is there is a non-return wall in this. Yeah, nothing can come out. So this also the main thing is non-return wall. What I designed, it will allow everything. Even small leaf can go inside, but that cannot come out. So this also, the pattern is an order of grant. This can be fixed in the boat. In a catamaran type boat, this can be fixed so that all trashes will travel while moving. The trashes can be collected, and parallelly, while transporting people, parallelly we can clean the water body. This I am holding discussion with authorities in Kochi, and Professor Madhavan is helping me, and soon we will have a trial. And I am ready to share the technology to the water metro. So they not only transport people, simultaneously the cleaning can also happen, because the non-return wall, it won't leave anything to come out. So this can be explored with the help of people. And this as a hand tool, the government of India, the functions, Swachh Bharat, they started distributing this particular device as a hand tool. This was a DST function to celebrate the Swachh Bharat Day. So Gandhi Jayanti. So they distributed to workers this in Northeast. So slowly it's getting popular, because this is a simple tool to keep the water body. The advantage in this particular tool, I given this ADATA, ATA, Aquatic Trash Avoiding Tools and Accessories. So the importance of this is, directly trash is collected the bag can be changed very easily. So the bag, whatever the trash, we can collect full bag, and the bag we can replace very easily. That is the advantage with this particular device. Actually, I developed this as a part of the as attachment for a boat, but later I found that this can be used independently to keep small water bodies. So with my capacity, I donated many temples to clean the temple pond clean. And I got very good feedback. It is very useful tool. So thing is, this the collection bag is only 10 rupees. So that can be used once filled, it can be replaced very easily. So that is advantage. But the main thing with this particular device is the non-return wall. Soon will be, I'll ensure that this will be available in gem purchase, so that anybody can purchase online, so that anybody can purchase and use for cleaning water bodies. So yeah, I think that's all. Yeah. So with this, let me conclude my talk. I plan to visit there, but due to some unavoidable circumstance, I could not visit. I apologize for that. But I am very thankful for giving me this opportunity. I am thankful to Professor Madhavan and other coordinators, Professor Shiv Prasad, the head of the department. And really, I feel very happy whenever I reach KUSAT, because I used to have a lot of discussion with them. They used to give a lot of motivation. So that this motivation enabled me to progress in these areas. Thank you very much.
Thank you very much, Professor Muthukumaran. That was a very inventive talk. Many new things that you have found out. Any questions from the audience?
Muthukumar sir, appreciating for your great effort for the socially relevant project. I got some question regarding friction stir welding.
Yes, sir.
So you have already shown on video that is the welding of tube and a plate.
Yes, sir. Yes, sir. Yes, sir.
Is
Yes.
it by friction stir welding or simply friction welding?
Yeah, actually, sir, that is my invention. I'll show you that particular slide. Yeah, you can see, sir, right side, you can see it is my invention. I invented this process 2006 and got patent 2008. I named this process as friction welding of tube to tube plate using external tool. It is exactly in between friction stir welding and friction welding. This is using external tool, but the bond interface will look like a line interface. That is okay. So this is my invention, and 4 people they explored this left many NDT part and strength, and we could publish around 25 papers in this, and many now abroad also they started publishing paper in FWT-PET. Google, if you put FWT-PET, it will come. So I invented this process FWT-PET, friction welding of tube to tube using external tool. So 2006 and 2008, if you're interested, I can share the articles, sir. I am ready to share the articles.
Okay, sir. Okay, sir. Another question. Is it possible to join aluminum alloy with the copper using friction welding?
Yeah, yes, sir. Yes, sir. Tube to tube plate we explored, and we published some 3 papers in that aluminum to steel. Aluminum to copper. We published some papers in that. Yes, tube to tube plate we are successful. And regarding if you want a transit joint, that can be explored by recent process I shown, that longitudinal joint. That also we can take.
Sir, but aluminum and copper is having huge difference between thermal characteristics.
Fine, sir. But this
Even-
is a solid state process. Suppose you are rightly said, not only huge difference in melting point, but also conductivity, but also intermetallic is a very big problem in mild metallic welding. Intermetallic. It will have a brittle intermetallic and it will have poor strength. You may get joint, but that joint may not be useful because intermetallic formation in case of arc welding. But this is a solid state welding process. So here the intermetallic formation is controlled because there is no melting of a line. But it is very tricky. It's very tricky, and we need to do the modification to achieve that type of joints. Yes, we can do it. If such work comes, we can explore.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Sir, good afternoon, sir. Sadish here.
Yes, yes, sir.
That surfboard you have donated to us is proudly kept in our laboratory. So
Thank you, sir. Thank you.
just want to thank you again because
Head of the department. Yeah, yes, sir. Yes, sir. Yeah, actually, as I said, they supported me. Without the CUSAT help, I would have kept this inside the lab. So that is a really big confidence that given, because so that given me. So it is my pleasure to donate, and I request you to add some 5 experiments, sir. And so that student definitely they would get better knowledge, sir.
we also assure cooperation for any of your new innovative projects, sir.
It is my pleasure to collaborate with you, sir. And if at all some cleaning happen, water body, we would be more happy. And definitely, it is win-win, sir. We'll collaborate. Definitely, we'll do something good to the society, sir. Thank you, sir. I take this opportunity to thank the CUSAT for giving me support in my journey. So any participants, it's my pleasure to share my experience, and you can see the Google also if more details are available. The interview I shared full detail about the Furboat. It's available in YouTube. Just if you put the Furboat, FUREBOAT in YouTube, you can find. Yeah, so I am ready, open for collaboration. Particularly, I think many alumni are in abroad countries. I welcome the alumni to collaborate, and I am ready to share whatever I learned to the as a benefit of the humanity. And as it is a PCT filed, 1 year time is available to file in different countries. So whatever filing, if suppose US somebody is interested, we can jointly we can file as an inventor, and we can work, and we can explore. So definitely, I hope US also there is a big flood, and recently Malaysia there is a flood. So everywhere flood is now because of climatic change is happening frequently. Definitely this will have some importance. I'm looking for collaboration. Yeah. Yes.
Professor Muthukumaran, I have Ebenezer here. I have a question. In a video that you showed, the metal was red hot, but you are not using any coolant. So what is going on there?
Yes, sir. Very interesting, sir. Actually, sir, the metal need to be reach plastic condition. The parent metal. The what I shown is tube to tube welding. Both tube and plate should reach plastic condition, because whenever we used to see, the forging, we used to use to red hot, then only we can forge. So around 80% of the melting temperature it will reach. So in case of aluminum, there won't be color change even after melting, but steel, it is a property. So when it get red hot, it will reach plastic condition. So we need to plastic flow should happen, because you can see right hand side of the figure, the gap, the metal moves and occupy the gap. So it is not only metallurgical bond, there is a mechanical interlocking happening. So right side, you can see the tool is there, pin is there. The material, plate material, arrow mark shows the movement of plate material in plastic form. So for that, we need to reach around 80% of the melting temperature. That is achieved by friction. So in case of steel, yeah, it should be heated, but the machine, nothing is going to happen to the machine because machine is not going to heat it. So this parent metal should be heated to achieve the joints, and we are able to get very good joint with this.
Professor Muthukumaran, we thank you very much for a very interesting talk, and we'd like to show our appreciation by giving you a certificate. It's an e-certificate, and we'll show it to you on the screen.
Thank you, sir. Thank you, sir. Thank you very much.
Thank you again for being with us.
Yeah. Thank you. Thank you very much, really. So, it is my friction welding. Some other occasion, it is my pleasure to give lecture, because this is my bread and butter. And whenever we are planning to organize a workshop on ship fabrication along with KUSAT. And moreover, now I was selected as a vice chairman in Indian Welding Society, IWS, Indian Welding Society, and southern chapter, and we are planning lot of workshops. I will also share the most of the workshops we are going to go do online workshops, and friction welding we are planning, and interested faculty members, student, and people from industry can take part. Let me share the details whenever we are organizing. So it is Trichy, our BHL. It is near BHL. So this area is called Mecca of Welding. Lot of fabrication work used to happen. So we have good expertise. Welding Research Institute is we are with us. So we have IWS, and we are very active. And let me share whatever activity we do. Interested people, I welcome to participate. Thank you, sir.
Yeah, congratulations, and thank you very much once again. Thank you. Bye.
Thank you, sir. Shall I stop sharing, sir? Yeah. Okay.
Thank you, Dr. Muthukumar, for your engaging and insightful presentation. We deeply appreciate your time and effort in sharing your knowledge with us today. With this, we conclude this session. A heartfelt thank you to all the speakers and the session chair for sharing their knowledge and expertise in the field of eco-friendly ship innovations. I now invite Dr. Sadish Babu PK, HOD of Department of Ship Technology, to present a memento to Dr. D.D. Ebenezer as a token of appreciation for his guidance throughout this session. It is time for our lunch break. Kindly proceed to the dining area. Use this opportunity to relax and engage with other attendees. We request everyone to be back in the hall by 1:30 as the next session will begin promptly.